Often we can run a combination of porosity devices into the wellbore together, thus allowing us to define porosity better than by using any single porosity device by itself. The most common pair is the density-neutron combination. This density-neutron combination log was run in a sand shale interval in a South Louisiana well. The neutron porosity and density porosity curves were run on the same matrix, in this case a sandstone matrix, and the scales are identical. Thus, in a clean, water-bearing sandstone, we should expect the curves to match each other fairly closely. Let's take a close look. Above the sandstone in the shale, the neutron log reads a too high porosity of about 40 to 45% as it responds to the high water content of the shales. From here to here, the neutron curve falls back to about 30 porosity units, while the density curve remains at about 15%, indicating relatively less shale. The zone is interpreted to be a silty shale or possibly a limey shale. The top of a sand body is indicated at a depth of 12,375 feet by the abrupt decrease in the gamma ray reading. A thin 2-foot interval of porosity is shown at the top of the sand, where the porosity curves average about 23% porosity. Then just below a thin low porosity bed, the two curves exhibit a marked reversal, with the density curve reading a high porosity value here of about 38%, and the neutron curve here reading a relatively low value of about 20%. We recall that the presence of gas, which has a considerably lower hydrogen concentration than water or liquid hydrocarbon, will cause the neutron curve to read too low. Also, the low density of gas compared to water or oil will cause the density curve to read too high. Thus, this type of curve separation on the neutron density combination log is often an excellent indication of gas. On our example, the separation extends more or less continuously from 12,380 feet to 12,408 feet, indicating a gas column of 28 feet. Adding this to the 2-foot interval of porosity at the top of the sand gives us a total net pay column of 30 feet. The curve separation is less over the bottom 10 feet of the gas column, indicating a transition zone to the underlying liquid column. The suspected presence of gas causing the separation of the neutron and density curves in our South Louisiana well tends to distort porosity readings. In such cases, charts for porosity determination become unreliable. One quick-look method is provided by the relationship where gas-filled porosity equals the square root of the neutron porosity squared plus the density porosity squared divided by 2. Thus, the formation porosity here at 12,283 feet is the square root of 0.20 squared plus 0.38 squared divided by 2, which equals 0.304 or 30.4%, close to the average of the two porosity readings. From the base of the gas column here at 12,408 feet to the bottom of the log, the two curves should essentially match, as we would expect in a liquid-filled sandstone, since both curves were run on a sandstone matrix. However, the neutron curve in many intervals, as we see here, reads a higher porosity than the density curve. This results from the neutron log responding to bound water in clays interspersed throughout the sand body. Now, let's examine porosity determination from the combination neutron density log run over a West Texas carbonate. Both curves were run on a limestone porosity index with a scale from 0 to 30%. First, note the clean carbonate formation established by the low gamma ray reading, from here to here. The dashed neutron curve here closely matches the density porosity curve, thus indicating a limestone lithology, and the apparent porosity is 5.5%. From 5,050 feet to about 5,078 feet, we see an increase in porosity, with the neutron curve reading about 2 porosity units higher than the density curve. At 5,075 feet, the neutron curve reads 15% porosity, and the density curve reads 11% porosity. Placing these values on a cross-plot chart of neutron density porosity constructed for limestone porosity and saltwater drilling mud indicates a porosity of about 13.5% and a lithology of slightly dolomited limestone.